Okay, go ahead and pull out the weekly worksheet again. We're going to finish going over some of those on the back. I think we're going to finish. We might have a little bit more to do tomorrow. So on the back, yesterday we refreshed our memory on how to compare decimals. For number 3, I'm not going to work that one out. You have lots of options there. You can use algorithm, you can use lattice. If you like to make your life hard, you can use partial products or area model. Number 4, I really don't think we have to go over. I think we're good. Number 5, I don't think we have to go over completely, but to refresh your memory, how do I divide and give my answer as a fraction? Harper?
Put your remainder as the numerator on top, and then whatever you are dividing by is your denominator.
Yeah, so everybody on your loose leaf that's attached to your weekly worksheet, we're going to work out a problem together. So everybody's writing this problem down on your loose leaf. 1, 2, 6, 4 divided by 6. We'll just do 3 because I know it comes out with a remainder. Okay, we actually know 3 different ways to give this answer now. So we're going to work this one problem and give 3 different answers. Okay? So to set it up, let's all set it up. 1,264 divided by 3. Brant, help me get started on this. Do you have it written down? Nate?
You can't do 1, so it's a 12.
Yeah, I see how many times 3 goes into 12. How many times does 3 go into 12? 4, so I put a 4. 4 times 3 is 12. 0. Haley, what do I do next?
Bring down your 6.
Drop my 6. Haley, how many times does 3 go into 6? Twice? Hey, Sophia, will you go shut the door just so it's quieter? Okay, 2 times 3 is 6. 0. Drop my 4. How many times, Brody? 1 time. 1 times 3 is 3. I subtract. Now, when I get to this point, I can give my answer as a remainder or using a fraction. I'm going to give the answers up at the top because I'm going to keep doing work to give my answer as a decimal. Any answer, we can give it as a fraction, a remainder, a decimal. Usually once you learn how to do decimal and fraction answers, the remainder answers kind of go away. In 6th grade, you will never give the answer using a remainder. You will either give it in its fraction form or in its decimal form. They're all the same value. They all have the exact same value. It's just giving it different ways. Okay? So up here, let's write equals, equals, equals. Because we're going to give that answer 3 different ways. Who can give me the answer using a remainder? Brady? 421 remainder 1. Draw a squiggly, just so I have some room in here. Okay? For a fraction, we can go ahead and give our fraction answer from right here. The 421 stays the same. The only thing I worry about is the remainder. How do I write a remainder 1 as a fraction? Maya?
1/3.
Okay, why is it 1/3?
Because the remainder is 1, and then the 3 is what?
Yeah, your remainder is your numerator on the top. Your denominator is always your divisor. Here's another way to look at it. If I wrote this problem, 1,264 divided by 3. Can I write that problem like that? Yes, that's the same thing. That still says 1,264 divided by 3. The denominator stays the same. What you're dividing by is your denominator. Okay? Anybody know how I can get my decimal answer? And this is a ugly decimal answer. I'll give you a heads up. How could I keep the problem going? Dane?
You put a decimal on the end of the 4 and the end of the 1.
Okay.
0 on the end of the 4.
I can add as many zeros behind the decimal point that I need, right? But I don't see a decimal point. If I don't see one, where is it? Behind it, yeah. So let's go ahead and fill in a decimal point now. If we fill it in to keep going, we also have to move it up into our answer. Now that I've dealt with my decimal point, I can add as many zeros as I need to get to a stopping point. In this one, we don't actually ever get to a stopping point, but I think you'll notice something. If I add a 0 and drop it, how many times does 3 go into 10? 3. So I put a 3. 3 times 3 is 9. Subtract, I get a 1. What can I do? Drop another 0. And notice when I'm adding zeros, am I adding them in the answer or in the problem? I'm adding them in the problem because I'm just adding them to the 1,264. That would be 10. How many times 3 go into 10? 3. I'd add another 0. I got to scoot down a little bit. I'm running out of room. So that'd be 9. Oops, moving stuff around here. That'd be 9. I got 1. I got 0. What are you noticing?
It doesn't stop.
It's never going to stop. Okay? So my answer, this is more of a 6th grade answer, which is fine. It's not difficult. As a decimal would be 421.3. There is a symbol that says, hey, this number is going to repeat forever. It's going to be 0.3333333333333 without having to write all of those 3s. Does anybody know what that symbol is? It's super easy if you know what it is. Sadie, do you know what it is? It's not an infinity sign. You just put a little bar over the top of the 3. And that is the mathematical symbol saying that that number is going to go on forever. It's called a repeating decimal. Okay, you can't have repeating whole numbers, but you can have repeating decimal numbers. And that is the universal mathematical symbol that says, hey, this is a whole bunch of 3s beyond there. Okay, that is the most specific answer we can give as a decimal. Okay, so anytime you're given a division problem, even if there's no decimals in the original problem, you could give your answer with a remainder. That's the beginning division. With a fraction or as a decimal. Okay, all of them have the same value. It's just different ways to give the same answer. Okay, let's look at one more. Let's go ahead and go to number 6. It was a little confusing because of my typo. But what did I tell you to change on it? I told you to change the word quotient to answer. Some of you didn't do that, so it was even harder. But number 6, the first one said, if you missed these, you're writing them down. 25,000 divided by 50. If I were working this problem, I would write it like this. Cancel. One set of zeros. What's 25 divided by 5? 5. How many zeros are left? 2. Okay, there's not a ton of work to show, but you should have a little bit. The next one, 3,600 times 400. 3,600 times 400. If you didn't mark out the word quotient and write answer, you probably would have put 9. But we had to take 36 times 4. What was it, 144? Somebody get it correct? 144? So that's 144, and then we add 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay, there was a typo there. I put quotient, but I told you to find the answer. Next one, 160,000 times 8,000. 160,000 times, is it 8 or 80? 8,000. First thing we had to do was 16 times 8. What's 16 times 8? 128. 128. And then there was 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Okay, put that aside. We will finish the last two tomorrow. We're going to go over those and do some more examples of those. Okay, so you've already checked last night's homework. Raise your hand if you missed some because your decimal point was in the wrong spot. All of your numbers were good, but your decimal point was in the wrong spot. Okay, raise your hand if you had the wrong numbers because you added, subtracted, multiplied incorrectly. So no one in here missed any? No problems? What'd you mess up on?
Number 5.
Okay. But was it like a mathematical error? Did you multiply wrong or subtract wrong? When you reworked it, did you find your error?
No.
You never did figure it out?
She's on your
Oh, I'm not on the weekly worksheet, on last night's homework.
Oh.
Last night's homework. Sadie?
I did. When I multiplied, I did the wrong number.
Okay, so a multiplication error. Okay, Lori?
Yep. I put the wrong number.
Okay, can you get the right answer to the wrong problem?
Yes.
No. If you're working the wrong problem, you're probably not going to get the right answer to the problem that I asked. And in the older grades, guys, you won't really use a book at all. You'll copy everything down on loose leaf just like you did last night and work the problem. Probably, I would say 50% of the errors, like that high, quite a bit of the errors are they copied the problem wrong. So, step 1, copy the problem correctly. You will never get the right answer if you're using the wrong problem. Unless you mess up so bad it kind of works its way around, but that doesn't happen very often. Okay, are there any from last night's homework that you want me to work out on the board? No? Okay, so we're going to move on. We're still dividing decimals, but today we're doing decimals by decimals. You do not need your book out. But I am on the page 455, I believe. You don't need it out. We're doing lesson 13, which is just called divide decimals. And it says, when dividing by decimals, change the divisor into a whole number. To do this, multiply both the divisor and the dividend by the same power of 10. Then divide as whole numbers. Okay, sounds confusing, right? On your loose leaf, we're going to write that rule in English, a little bit better English, that makes more sense to you. So go ahead and title it Divide Decimals. Divide decimals. And then we're going to write our rule. I'm going to try and, I can't make it in fewer words, but I can hopefully make it in words that make a little more sense to you. Nate, you need to copy this down. Okay, so our rule is we must divide by whole numbers, which means our divisor must be a whole number. Okay, our divisor must be a whole number. Last night, we were lucky and that worked out for us, right? Today, we'll be dividing decimals by decimals. The book said if you're dividing by a decimal, you have to multiply the divisor and the dividend by a power of 10. We just worked on multiplying by powers of 10. What happens to our decimal point when we multiply by powers of 10? Maya?
It's,
We don't ignore it.
it moves
It moves which direction?
to the right.
To the right. 10 times to the right. If you're multiplying by a power of 10, our decimal point just moves to the right. Okay? So the rule to help you, the shortcut rule, what we're going to write down and then I'm going to explain it in more words, is move it over, over, over. Sometimes it's 1 over, sometimes it's 2, sometimes it's 3. Move it over, 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 and up, up, up. Okay, that's our trick, just to help us remember the long rule. Brady, put the calculator down. We're done with it. It's not a toy. Okay, what does that mean? It means, we're going to write that means if the divisor is a decimal, move the decimal point to the right until you have a whole number. So if the divisor is a decimal, you move the decimal point to the right until you have a whole number. That's where the move it over is. You move it over to the right until you have a whole number. Then you move the decimal point in the dividend the same number of times. So you move it over in the divisor, over in the dividend, and then up into the answer. Next, I know this is a lot to write, but you have something to look back on. Move decimal point up into answer and divide. And really, this isn't a whole lot of work, but I'm putting it into words so that you have something to go, and because you'll do part of it. You will move it over on one of them, but you won't move it over on both of them. We'll talk about why it's important to do both in just a second. Move it up just slightly. Dane, how far are you?
I'm
we're going to practice doing just that, the first part, getting it to look like last night's homework, okay? So in the book, they could give us a division problem like under the box. They could give us a division problem written horizontally with like the divide sign. They could even give us a division problem written as a fraction, okay? When you're doing these ones, I want you to always write it out in horizontal format first. I don't care how they give it to you in the book. I want you to copy it down in the horizontal format, okay? What do I mean by the horizontal format? Maya?
Like the dividend goes first, and then the divide symbol.
Yeah,
and divide symbol.
dividend, divide symbol, divisor, okay? Because we have to move our decimal points in these. So we're going to do it there, and then we're going to go work it. I don't want you moving and working all in the same spot because you'll get confused on where your decimal point is supposed to be. Okay, so here are some examples. I want you to write this down. Oops. $126.5 divided by 1.2. Our rule says move it over, 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 and up, up, up. Which number cannot be a decimal? Which number cannot be a decimal? Parker?
Well,
the 1.2. I want you to draw an arrow right here. That number is the one that cannot be a decimal for us to be able to work this out. Can our dividend be a decimal?
Yeah.
Yes, that's just like last night's problem. Okay, so we look at our divisor first. We have to move our decimal point to the right until we get to a whole number. How many times am I going to have to move it? Once. I want to see your one loop. Show me I'm moving it one time. When I move it one time, what is my whole number? 12. But what I do to the divisor, I also have to do to the dividend. So how many times do I need to move that decimal point over? Once. So I'm going to show it. What is my new number? 1,265. And then that's the problem I would set up under the box and solve. Does anybody know why it's legal, math legal to do that? The math police aren't going to come looking for you? You might know what we call those two types of problems. You probably haven't heard it in this context. They are equivalent. What does that mean? Equal. If I divide them out, I will get the same answer because they are equivalent. Because really, I multiplied that one by 10 and multiplied that one by 10. So I multiply them both by the same amount, so I should get the same answer when I divide it out. Just to prove it, the top one says 126.5 divided by 1.2. When I type this in, it's ugly, but I get 105.416666. It's 6 repeating. Okay, and notice on a calculator, I'm going to go ahead and point this out, it says 7 at the end. Why is it not? Why do they put a 7 at the end, Harper?
Because there's 7 sixes.
No.
There's only 4 sixes.
Calculators are smarter than we give them credit for. They round the last digit. If it's off the screen, and if you, like I see 6666667, that last digit is rounded. It's not that there's a 7 in there. They know you can't just chop off digits, so they round it at the edge of the calculator. When I type in 1265 divided by 12, I get 105.4166666 because these two are equivalent. That's why we can do this. Okay, that's why it works. Let's do another example. And again, I'm not dividing it out because we divide just like we would yesterday. We're just getting it set up properly. Let's do 3.456 divided by 0.24. Finley, which number cannot be a decimal? 0.24. So that's where we start. That's the one that tells us how many times we move our decimal place in both of them. Sophia, how many times do I have to move my decimal point to get that to be a whole number? 2. 1, 2. So I'm going to move it right there. So my whole number is going to be what? 24. So if I move it twice in the divisor, I have to move it twice in the dividend. Once, twice. So I would be taking 345.6 divided by 24. When I go to set that up, I would have to move my decimal point straight up into the answer. Okay? So is this too terrible?
No.
No, it's just an extra step. Here's where you're going to mess up. You know this can't be a decimal, so you'll make it a whole number, and you'll forget to do it over there, which will put your answer off by times 10, times 100, or times 1,000, depending on how many times you had to move your decimal point. Now we're going to work some problems from beginning to end. We're not going to get through a lot because that's really the new stuff, okay? That's the new stuff. We're going to work a couple. Let's do 16.5 divided by 0.03. Copy these down, guys. I'm not doing them for me. Jude, where do I start?
You start moving the decimal point at the 0.3 over.
Yeah, because I have to get that number to be a whole number. How many times do I have to move it, Jude, to make it a whole number?
2.
Twice. So I'm going to show once, twice. So my new problem is something divided by 3. Because do I need to write 003?
No.
Nope. Max, if I move it twice in the divisor, I have to move it twice in the dividend. What is going to happen here?
You have to add a 0.
I have to add a 0. So I'm taking 1,650 divided by 3. So let's go out to the side now. We're actually going to solve this. I'm going to go ahead and put my decimal point there. Will I necessarily need it? No, but I'm going to put it there just in case. If I have nothing behind it, do I have to put it in my answer? No. How many times does 3 go into 1? 0. 16. 5. 5 times 3 is 15. I get 1. Drop the 5. How many times 3 go into 15, Brody? 5. 5 times 3 is 15. Drop a 0. How many times does 3 go into nothing? 0 times. And then I still have nothing left. So do I really need my decimal point in this one? No. What is my answer? 550. 550. So if I took 16.5, divide, and really what that's saying is, this is like pennies, okay? I have 550 sets of 3 cents to get $16.50. It's kind of what that's saying. Okay, is this really much different than what we did yesterday? No, we're going to do one more, and then I'm going to give you your homework. Harper, pick a number between 2 and 13. 12. Okay, 12 works. 12 says 13.2 divided by 0.3 equals D. Does that really change the problem at all? No, it's just saying the number we're looking for, instead of calling it blank, we're calling it D for something I don't know. Kendall, help me get started.
You do the decimal point in 0.3 over 1 time.
Okay, so that will make my whole number 3 again. Okay,
And you move it in the dividend 1 time.
okay, and I want you to notice on your loose leaf tonight when you're working, I want to see the original problem I want to see your loops that you're moving it. Write out your new problem before you start dividing. That will prevent you from making goofy errors. Now I'm going to divide it out. I'll leave the decimal point off. We can add it in if we need it. Abby, how many times does 3 go into 13?
6 times.
Lower.
4 times.
4 times. 4 times 3 is 12. I subtract, I get 1. Drop my 2. Maya?
4 times.
4 times again. 3 times 4 is 12. So, our answer is 44. And if you put 0.0, you're not wrong, but we don't need it. Now, will all of your answers be whole numbers? No, not necessarily, okay? So now, open your books to page 457. I'm going to give you 5 of these for homework. I'm just going to tell you which ones to circle. Yeah, I'm going to give you some with whole number answers, some with decimal answers. I'm not telling you which are which. Okay, on page 455. Or wait, what did I say? Not 455. 457, sorry. I want you to do number 4, number 5, number 7, 8, and I'm just giving you one more. Number 10. I'll give you one hard one. 10's a little bit hard because you're dividing by 15. Where do you think I want you to do those problems?
Loose leaf.
On loose leaf. Okay? Weekly worksheet is due tomorrow. You do have Chromebooks today. Okay, so use that to your advantage.